So good evening, everyone. My name is Kelsey Doerksen, and I am a space systems engineer at Planet. I started about 4 weeks before work from home was in order for the San Francisco office. So I got only a little taste of what it was like to work in the physical San Francisco office, but I'm really happy with my past 5 months being a part of the team. Today I'm going to be talking a little bit about how to handle big data in space and the different machine learning projects I've been a part of over the past few years. And so I'm just going to jump right into it. So first I want to start off with what is machine learning and what do I really mean by big data? So big data is really just that. It's a large volume of data or a lot of data. And we use machine learning with this big data to seek statistical patterns, to enable computers and algorithms to make either a classification, such as differing between pictures of dogs and cats, or prediction about the data. I really like this three-step image here that basically breaks down what machine learning is really at a high level, where you start with this big conglomerate of data, you can't really make sense of it or extract any meaningful information from it. You apply analytics to it, and in this case, it would be a machine learning algorithm. And from those analytics, you're able to make informed decisions about the data in question. So I'm going to be talking about 3 different projects I've worked on at a very high level. So don't be worried if you don't know anything about machine learning. And I'm going to start off with my first project I worked on, which has to do with machine learning on Mars. So for those of you who are unfamiliar with the Mars Exploration Rover mission, this was a NASA mission that launched in 2003, and it sent 2 twin Mars rovers, Spirit and Opportunity, to the surface of Mars. Unfortunately for the Spirit rover, its wheel actually got stuck in the Martian soil. You can see in that black and white GIF image there, that is taken from the Spirit rover itself. And unfortunately, the mission was lost in 2010 for the Spirit rover because its wheel was stuck in the sand and they weren't able to get it free. So how could we have used machine learning in order to prevent this from happening for future Mars rover missions? As we know, Perseverance is launching hopefully soon, barring any delays. So this is a project I worked on at the NASA Jet Propulsion Lab called the Barefoot Rover project. Essentially what the Barefoot Rover project purpose was to use what is physically felt by the Mars rover wheels to be able to detect different things about the surface it was rolling across of. So my work was specific to making sure the wheels were not slipping or sinking into the different types of sand material we had at the JPL campus. And it was also, I worked on the terrain classification and detecting if there was any subsurface rocks that could possibly penetrate the wheel and cause damage to the wheels. How this worked from a machine learning perspective, at a very high level, essentially what we had was a yellow pressure pad wrapped around the outside of the Mars rover wheel. And we took those pressure pad readings and trained that in a classifier to be able to detect these things that are on the bottom of the slide there. So we were able to tell the hydration content of the soil, anomaly detection, safety and stability of the rover, slip and sinkage, which is what I worked on, terrain classification, rock detection, and other different terramechanical properties. So this is a really cool project I worked on, and it's going to be implemented on future Mars rover missions. The second project I'll talk about is machine learning for the sun and for our Earth's atmosphere. So this very terrifying image you see on the slide here is a picture of a coronal mass ejection event. What a coronal mass ejection event is a huge explosion on the surface of the sun. And essentially what happens is these huge explosions send out high energy particles into space. You can see there, Earth is to scale in terms of the size of a coronal mass ejection and the sun as compared to the size of our Earth. The distance is not to scale, but the size of the 2 planetary bodies is. So why this is of concern, other than the fear that it strikes, of course, from this image, don't worry, it's not going to cause any, the flames will not reach our surface. But what they do is send these high energy particles to our Earth's atmosphere that essentially push our satellites around. So from a satellite operator perspective, the satellites can actually be moved off of their orbit path and collide with other objects in space, which is obviously really detrimental to the satellite operators. How can we use machine learning to tackle this sort of problem? Well, we can't stop these coronal mass ejection events from happening. Pictured there is a GIF image from the SOHO telescope that is showing what a coronal mass ejection looks like. So we can't stop these huge events from happening, but we can at least try to learn as much as possible about them and how they are affecting our satellites. And this was my master's thesis work using the satellite accelerometer data to detect these solar storms. So I mentioned before that these solar storms send out huge amounts of high energy particles, and they reach our Earth's atmosphere. The way you can think about this is if you're walking outside and it's very, very windy and you're getting blown back by the wind, that's kind of what's happening to our satellites when these particles reach our atmosphere. And that can be captured in the satellite acceleration data. The two graphs I have pictured on the slide here, the top graph shows the acceleration of the satellite when there's solar storm happening. So you can see the signal is quite erratic, and it's actually doubles and above in the linear acceleration of the satellite itself. Whereas during a period when there's no sort of solar storm, the satellite is very periodic and the signal isn't fluctuating at any alarming rate. The last project I worked on and want to introduce is, of course, using planet data, and this is machine learning for our Earth. So I'm really happy to be a part of the new partnership with the Frontier Development Lab and Planet, which is an 8-week research sprint with the NASA and SETI Institute. And Planet is working with the Waters of the United States team, which is using Planet's daily imagery with machine learning to assist with drought detection and prediction in small streams in the continental United States. So pictured here is the Seminole Reservoir in Wyoming, United States. And the first signs of droughts can be identified in the small streams that branch off of large bodies of water like these. So by comparing pixel values in these streams, using Planet's daily imagery of sites similar to this, the team of researchers will be able to detect and predict future droughts across America with the aim to scale this work to other areas across the globe. Can't get to there we go. So I really hope you're interested and able to follow along with those 3 different projects I worked on. I think machine learning, it's such a new and growing field, and space is the perfect application for machine learning because we have so much data. And if you have any questions, you can feel free to reach out to me. And thanks very much for your time. I said that tonight. We could all be stars. I said that tonight. We could all be stars. I said that tonight. We could all be stars.